Okay, so tonight, I'm probably just going to be reiterating some things that we've gone over before to try to clarify some stuff that I've seen as I'm grading the assignments that people seem to be getting confused on, or maybe just cleaning things up a bit. Most of the stuff that I've seen is pretty good, but there's little fine points of it that somebody that knows what they're doing would look at it and say, not quite doing it right. Tighten this up a little bit. So I just picked this problem at random, just some problem that you might encounter and be asked to work on. That's not our assignment. I'm just using it as an example so I can pull some stuff out from it and just talk about the different kind of diagramming tools and how we would approach something like this. So the book talks about an IPO chart. Does anybody remember what the IP and O stand for? We've talked about these, not necessarily in these terms, so it shouldn't be completely unfamiliar. Any guesses? What three things are our flowcharts and our pseudocode concerned with? I's, P's, and O's. You're probably right. No guesses?
Inputs.
Yeah. Yes. So an IPO chart is the inputs, the processes, and the outputs. The reason why they call it an IPO chart is no more complicated than that. However, the form that this takes is typically, Tim's going to die on me. I'll do it over here. I, P, and O. So you would just have three columns: inputs, processing steps, and the outputs. And it's just a list. We're not creating a flow chart. We're not leading to writing source code. It's not Python, nothing. We're just making a list. We're taking inventory. And that's all it's supposed to be. We're not supposed to overthink the problem. We're not supposed to get into solving any of the puzzles or the problems. We're just going through the problem and making a list of what we see. It's a very, very preliminary surface level scan of the problem. The only reason I get a little pedantic about this is that there have been assignments where I have intentionally made it a multi-step exercise. First do this, then once you've got it working, go back and add this to it. And I've noticed that a number of people never went back and did part two. You have to scan the problem to make sure you get the full extent of the requirements before you start, so you don't forget about that kind of stuff. It's sort of like your checklist, or it can be used as sort of a checklist. So the inputs to this kind of a problem would be, we go through the problem and read it and look for what inputs we're going to need. So pick a random number. Are there any inputs on that line?
45.
That would be doing this, but we're looking for an input to identify an input type piece of data for a program later. And the reason why I put this one up there is it's kind of a trick. It's something we need to think about, but it's not technically an input. It's like the when this last program talked about assume the number of days in a week is 5 and assume the number of days in a year is 252. You were just given those values. They're not input values. They're just important pieces of data for us to keep track of. So you would not want to say, ask the user for the number of days in a week. No, we already know that it's 5. We were given that in the problem. You wouldn't say, ask me how many work days there are in a year. No, we were given that. It's part of the problem, 252. So our input was simply the number of hours worked and the hourly pay rate. Those were our only two inputs on that problem. So similar here, when it says ask user to enter a number 1 to 100, that's our first input. A number. Are there any other inputs? I don't see any. No. Okay, our outputs. Notice I skipped over the processing. For me, that's just easier. I identify all my inputs, I identify what I need to output, and then I can map what calculations I have to do to figure out how to get from what I'm given to what I need to produce. So my outputs. What are my outputs on this problem? Yeah.
Too high, too low, or correct?
Bingo. Too high? I mean, this kind of a problem isn't like where I had to output the miles per gallon, right? I'm given the hard-coded strings that I need to say. Too high, too low, bingo. Right? So I have made a list of my inputs. I've made a list of my outputs. My calculation steps that I need to go from one to the other are, on the mileage one, it would be compute the miles per gallon given the miles and the gallons. So I would say calculate the MPG here. On this one, I don't really have any math problems to solve, right? So I guess I don't really have any processing statements. I'm going to have those if statements. To see if my number is higher or lower than what my guess is. But that's about it for this problem. And that's okay, because all I'm doing at this stage with the IPO chart is making a list of them. And then I'm supposed to repeat. And we haven't talked about repetition yet until next chapter, but keep going until the guess is correct. Yeah, there's no processing steps there either. That's okay. I would say that I'm done. If I want to make a note here that's, there's some repetition to go there, great. This has served its purpose. I'm done. I can move on to the pseudocode or the flow chart. That's basically all there is to an IPO chart. So if you've been trying to look at those in the book or trying to incorporate those in what you turn in, you're done. That's it. We've taken an inventory of our problem and identified the important bits, and now we're done. Any questions about IPO charts? As your program gets more complicated and you have lots more calculations to do, if you're doing some kind of business accounting software where you have to calculate, return on investment or EBITDA or whatever those complicated accounting values are required, yeah, you may have a lengthy list of processing statements that you have to do. And this is a way for you to get organized, and you don't have to know how to make the calculations. Like if we were doing the miles per gallon, you just say, yeah, somehow I have to go Google, how do I calculate miles per gallon? But, we're just making a list of them at this point. We're not trying to solve any problems because it's completely preliminary. It'd be like a builder on a house saying, well, what are we talking about here? Are we talking about a Rambler? Are we talking about a two-story? Are we talking about a McMansion? What are we looking at here? You're just getting organized. Okay, so that's IPO charts. There's something else called a sequence diagram. And they serve a purpose we haven't really seen yet, which is to let different components talk to each other, or what we would call actors interface with one another. This might be like if you were going to go buy a car, you would say, okay, I've got customer, I've got salesman, and I've got the manager. So the sequence diagram we built up out of all of the things that can happen between those three actors to accomplish what we're trying to accomplish. Let's say we're trying to buy a car. So you'd say the customer asks to see a car. The salesperson shows car. The customer says, what price? The salesman says, I don't know. Let me ask my manager. Asks price. Manager says, fake it. Salesman says, don't know what we can do here. Maybe make an offer. The customer says, offer 10K. The salesperson says to his manager, this guy's crazy. Try 20K. So he comes back here and he says, try 18K. Okay, but this is basically just describing the conversation that happens between these three actors until, okay, fine, we've haggled, we all agree, and then the customer leaves with the car. I could keep going forever, but I think you get the point, right? Where it applies more to us would be a user talks to a web server which talks to a database. So the user hits a submit button on a web page. The web server says, enter credit card. The user submits credit card. The web server saves credit card. There may be other actions in here. Before we save it, we might, make this a little bit more realistic. We talk to the bank and say, check the credit card, see if it's a valid credit card. They come back and they say, it's okay. So then we say, store transaction. The database says, okay, I stored it for you. And then we return to the customer and we say, okay, you just bought it, right? That's more of a realistic kind of transaction that would happen in a software environment. And the where that would come down to the kind of stuff that we're doing is when the user is clicking submit on a web page, maybe we're writing this software component and we have to know how to display the web page, how to implement the submit button. So when the submit button gets clicked, we send a request off to a web server. Then there's another component here at the web server that says, hey, somebody might click on a submit button, which may call us. We need to know how to take that information, process it, and return a result. Or we may have to send requests to other components on other machines and process what we get back from them. So software developers, you might have working in the user interface layer, working on this, writing a whole bunch of code, whole bunch of programs that implements what you see on the web server or on the web page. Another developer is writing all the stuff that processes that data on the web server, and et cetera. And so that's where it gets interesting to us. And you can understand how, the simple programs that we're writing, eventually, after you write several thousand lines of code, you can develop some really sophisticated processes by doing this. But boils down to when you see a diagram that looks like this, that's called a sequence diagram because it tells you what is happening between each of the actors in what order. And that way everybody kind of knows what the rules are and can go off and implement their piece of it. There's some really neat tools out there for developing this stuff. And that sort of goes along with my whole theme of diagrams today. Let's see how I can bring this up. Hopefully that's low enough. There's this technology somebody wrote called Plant UML. UML stands for Unified Modeling Language, and it is simply a standard for what all the boxes and the arrows and things like that mean. Actually, I don't like this one. I'm going to go here. So this is a much prettier website that's based on Plant UML technology. But if you can see what that is doing up here, everybody read that text now? Camera pointing at it, so it won't get in the recording. Okay, so we're creating a diagram similar to the ones we were looking at. We can give it a title. And notice how over on the right, it in real time changes to what I just typed. So that's kind of nice. Alice and Bob in this example are both actors. And then the label for what is happening in this operation appears above the arrow and is here. And the little dash greater than in between the two actors specifies what the transition is. You know, so you know, Alice to Bob, then Bob back to Alice, and then I could say Alice bank. You know, so you keep building up this thing. But I like this tool because it's very easy to use and creates these awesome looking diagrams for you. So if you ever find yourself in need of creating a sequence diagram like this, then you know, it's a nifty tool. See real quick what else I want to show you. Yeah, that's pretty much it. So like I said, short lecture tonight. I'll let you guys keep working on your programs. And next time we will get into the repetition stuff. Okay.